At lesson 42, which is solving problems involving percents and writing proportions and percent statements. Okay, so we will use a couple of different methods to do percent problems. Everything we're going to do today is pretty much review. So this is a good I'm tired and it's Monday kind of lesson, Brooklyn. All right. Okay. All right. So let's have some definitions first of all. A percent is a ratio that compares a number to 100. You don't really need to write this down. Most of it's going to be kind of real elementary. A percent is a ratio that compares a number to 100. What does percent mean literally if we interpret it?
Part of 100.
Per doesn't mean each.
Isn't it like of 100?
Per means divide.
Oh.
That's exactly right. So percent literally means divided by 100. Okay, that's literally what percent means. Okay, so it doesn't mean part of a whole. It means per 100, which per is one of the words in mathematics that indicates division. Okay. So per 1% means divide by 100. Yes. We'll talk about that later. So, for example, 50% is a ratio 50 divided by 100. Okay, 50% is 50 per divided by 100. Okay, there's three components that form a percent, and we're talking about, somebody mentioned earlier, said parts of a whole or part of a whole. The percentage is the part of the whole, is percent over 100. So there's a part, there's a whole, and then there's a percent that tells the relationship of the part to the whole. Okay, and if we know two of the components, then the third component can be determined using an equation. We'll always have enough information to write an equation. Now, using an equation, now this is kind of where I want to challenge you a little bit, because a lot of these problems are going to be simple enough for you to do mentally, but I want you to use an equation, follow through a process. So a problem that you can't solve mentally, you have a process available that you could use for a more difficult problem. Process is more important than the answer. Okay. All right. So let's write an equation from this statement. What number is 50% of, 25% of 50? X equals what number is 25% times 50?
Can we do it in decimals, or do you want
You can, but it's easier to not. Very often. If it's not a calculator problem, which these aren't, none of the problems we're going to do today are calculator dependent, except for the easy problem. Yeah, you wouldn't think of it that way, right? But if you change this into a decimal, you're kind of making it a little bit more complicated for yourself. Yes. Yeah, because the directions say using an equation, so I'm looking for an equation. A test question could just say, what equation would you use to solve the problem? All right. Now, I know the mental processes that you can do. 50% is half of, 25% is half of 50%, so take half of it and half it again, right? That's one of the things you could do to get the answer. But here, 50 goes into 100 twice, and 25 divided by 2 is 12.5.
Can you leave it as 25 divided by 2?
Yeah, sure. 25 over 2 is fine. Now, 12.5 is what we're looking for here. Now, if we were talking about money, yes, we want to give it in proper units. Nobody would ever say 25 over $2, right?
That sounds wonderful.
Yeah. So kind of let the problem match the form of your answer match the problem. So this is, again, similar problem. What number is 125% of 64? A direct interpretation. What number is 125% of 64? Okay. What would we get here? 80?
Wait.
That's correct.
How do you do that so fast?
Well, in this case, it's kind of there's a lot of different ways to think about this mentally, right?
Can I change? Okay.
125% is 100% of the number plus 25% of the number. So it's 64 plus 25% of 64. So we're kind of thinking of this as you're really unwrapping it in a distributive property kind of way. So 25% of 64 is 1/4 of 64, which is 16. So it's 100% plus 16. 64 plus 16 is 80. All right? And you could also do 1.25 times 64 and work it out that way. Okay? That's equal to 1 plus 0.25 of 64. That's equal to 64 plus 1/4 of 64.
Could I do 5/4 times 64?
Yes. 5/4, you reduced this and did 5/4. You could even do go better than that, Brooklyn. You could do 5/4 times 64. 4 goes into 64. 16 times 5 times 16 is 80.
I tried to do that and I messed it up very badly, but it's all fine.
On some of them it won't
Okay.
work, or it will work.
Well, I mean, it's if we were talking about 127% of 64, then it becomes a completely different kind of problem. Yeah, there's going to be multiplication, decimals involved, or calculator work. All right, every percent problem can be set up as a proportion, and that proportion is this. Is over of
Oh, yeah.
equals percent over 100. Part to whole equals percent over 100. Okay, now this ratio or this proportion always works. Is over of equals percent over 100. It always works if we're trying to find simple percent problems like this one. What number is 125% of 48? Again, I want to see the work. I want to see the process. Okay, I want you to do example 3 using a proportion.
So, wait, what?
See, Charlie, you're rushing through and already trying to find the answer. And you don't have the process, though. The process is more important than the answer, always in mathematics. Don't be in a hurry. This process is important. So the proportion that I want you to use is the is part over the of part equals the percent over 100.
Does the percent have to be over 100?
Always.
It's never over, like...
No. So the is part is
Oh.
x. The of part is 48 equals the percent over 100.
How'd you get the X?
Because that's what you're trying to
That's the
figure out.
is part. What number? There's your x. Your variable. Remember, what number in just like the first couple of ones that we looked at, we did a direct approach. What number is 125% of 48? So this is just a different process. This is a direct approach. This is the ratio or proportion approach to it.
Did the girls tell us what is over of?
Yes.
Okay, just making sure.
Well, she told us.
She probably would have.
I
Yeah.
remember this.
All right. So then we would solve that, right?
Mhm.
We could change this to 5/4.
Yep.
Cross multiply, and you get 4x equals 5 times that's 240. Divide both sides by 4, x equals 60. Now, I always want you to make sense out of this, okay? Does this, if we go back and look at our original statement, does it make sense that to say that 60 is 125% of 48?
Yes.
It does make sense, right? We could also plug it right back into our ratio. Is 60 over 48 equal to 125 over 100? Do those both simplify to be 5 over 4? 12 goes into 65 times, 12 goes into 48 4 times. And this is 5 over 4. So 60 works. Make sure that your answer makes sense. Take a minute to think about it and make sure that there's good number sense involved. All right, using a proportion, same thing. 15 is what percent of 45? Okay. Is over of equals percent over 100. The is part is 15. The of part is 45. What percent? X over 100. Okay. It's always nice to simplify this fraction. 15 over 45 simplifies to be 1/3. All right, cross multiply, we get 3x equals 100. So x, our percent, is 100 divided by 3.
Which is like
33 and 1/3 percent. How do we know to put a percent there?
That's what percent?
What
So if it says
percent?
what percent, can we leave it as a fraction?
Well, you're not gonna say 100.
Or are we gonna have to divide it out?
Yeah, you need an answer there, right? 100 over 3% doesn't really work for us.
Could you say 33.3?
Sure. Mm-hmm. Okay. All right. Try this one on your own. Okay, is over of equals percent over 100, so 15 over x. So of is the x, 15 is the is, equals 20 over 100, right? Then we can simplify the fraction. 20 over 100 is 1/5. Cross multiply, we get x equals 75. Does that make sense? Is that a good, is 15 20% of 75?
Sure is.
1/5, right? All right. Let's look at a couple of money examples of where we can use a percentage. All right. Now this says calculating wages. Anna receives $1,153.84 in gross earning. So this gross earning, there's a term we need to know what it means. And you guys, probably most of you have never had a steady job. So you don't understand that. You may not understand that terminology.
Without taxes and stuff.
That's the total amount you make before anything is deducted. Okay? This is your regular earnings plus your bonuses plus whatever income you have, all of it lumped together before anything is taken out. All right? That's what gross earnings is. And then the equation here, the rest of the problem says that he takes 28.07% of, powerful word, of the gross earnings, and those are removed for taxes and other deductions. Use the equation. There's our instructions. How are we going to do this? Using an equation, we're going to determine the net pay. Net pay is what you reach down into the water and pick up. It's what you actually catch. It's what you actually take home. That's right. It's what you take home from this. It's what you net. All right. It's literally a fishing term. I don't care how much money is in your gross pay, how much are you actually bringing home. Okay. So what would the equation look like? For net pay, let's just talk about it as a concept. Let's use N for net pay. What is the net pay equal to in this?
28.
No, not specific. Let's look at it generally. It's equal to the gross minus the taxes. Okay, now we could go a little bit further and say that the taxes are 28.07% of the gross. Right? All right. So if we actually make everything, if we actually put this into the equation, we're going to have $1,153.84 minus 28.07% of $1,153.84.
Oh, okay, I get it. No. I'm very confused. I get it.
On this
This is
one,
not multiplication.
can I just do 0.2807?
It's like when you're doing, like, tax-
Can you not just divide?
Well, it's like when you do tax on a bill, you can't just have like you have to do the tax
Can you not?
of the entire bill.
That's right.
And then
Yeah.
add that to
And this is
the
why I
bill.
said that the key word here is of. Your percent in a practical application, your percent will always be multiplied times something. Percents cannot stand alone.
It has to be deducted or added.
That's exactly right. Okay. Now, there's another way to approach this, and we'll talk about it in a second, but this becomes a calculator issue. From here, you change that 0.2807 times 1153.84 and subtract it from 1153.84. Not something that I want to ask you to do by hand at the moment. Okay. But that's how you would set this problem up. Now, here's another way to approach this. Y'all want to see? I just want to kind of throw this out there so you can see it. If we're taking away 28.07%, how much is left?
I don't know.
52.93%.
I'd go with 71.
71.
The net pay is 71.93% of 1153.84. Now that's another way to look at it. Okay? Now you need to be able to kind of think both ways. Right? If something is 25% off, how much is left? 75%. So we can take the price and we can subtract 25% of the price, or we can just take 75% of the price. All right. Now, if tax is 7%, and we can take the price and add 7% of the price, or we can just do 107% of the price. So if we're increasing something, or the sales tax discount is this is like a 28.07% discount. Of course, none of us want to discount our pay. Yeah. All right. Last example of the day. Dominic earns. There's a couple of typos here. $9.25 an hour, working part-time. The circle graph shows how he divides his earning. All right, so we got 10%, 40%, 50%. That's all of it, right? Circle graphs have to be parts of a whole, so we need to make sure it's valid, and it is. All right. This month, Dominic has worked 54 hours. Find the amount of Dominic's earnings that will be put into savings this month. So what do we need to do? What's the process look like for this problem?
Multiply 9.19.
Yeah, his total pay, or his pay, is going to equal 9.25 times 54. It's 9 times 54, which is 476. Right. Plus 25% of 54.
Yeah.
Okay. Was what, 1350? So $499.50.
Sounds perfect.
Okay. Now we need to put that into. We can put it into our is over of equals percent over 100, or we can just do it directly, right? What is 40% of 49,950? What is 50% of 40% rather of that? So we could do it that way. Or again, you could just directly multiply 40% of $499.50. I think it's $199.80. Is that right? I don't know. Whatever that is. That's the answer. Okay? Any questions? All right. Your homework is page 266. I want you to do A through D, 1 through 15, and 18 through 30 even. All right, guys, I want to see good processes in your work.
We're starting on it now.
Yes.